Hello class. Today we're looking at section 6.1, simplifying rational expressions. On page 369, it talks about the definition of a rational expression. It says they are expressions where the denominator and or numerator are polynomials. Expressions where the denominators and or numerators are polynomials. We're going to talk about some key things in this section. We're going to continue to review over our factoring. So remember all the different strategies that we have covered. We still need to apply that in this section. We're going to talk about domain. And we're also going to talk about a negative switch order. So it's a lot of different things that we're going to talk about in this section. And I may be doing a lot of vocabulary, so please make sure you write down the vocabulary and make sure you have a good understanding of what each vocabulary term means. Turn to page 376 and let's look at number 33. Number 33 says find the domain. Domain involves the x values. So when you think about an ordered pair, domain involves the x values. So when I say domain, I want to know what's going on with those x's. On 33, we have f of x equal 4x squared plus 3x over 5x minus 2. When I see f of x is just like saying y. So when you see f of x, you might say y equals. F of x is a function. A function involves an input and an output. I will put something in for x, and it might be any number I could think of on the number line. I'm going to put in that number for x, and my result will be my output, which represents your y. So f of x is a function. It means an input and an output. I am putting something in for x, and what I get out of it is going to represent my y. It's a lot, but as we continue our notes, I want you to think about what I said. We're focusing on finding the domain. To find the domain of a rational expression, you take your denominator and you set it equal to 0. And then you solve for x. Add 2 on both sides. I'm left with 5x equal 2. Divide 5 on both sides. So x equal 2 over 5. So what does this answer mean? Well, domain cannot have two things. It cannot have an answer that is imaginary or not real. And it can't have an answer that's undefined. If I plug in 2 over 5 for x, just doing a check, if I plug in 2 over 5 for x, the 5's cancel, and I'm left with 2 minus 2, which equals 0. That means I'll have a number divided by 0. If I see a number divided by 0, that makes the answer undefined. So a domain cannot have any undefined answers, and it cannot have any imaginary answers. So when you hear domain, it represents the x values. It cannot be an imaginary number, which means not real, and it can't be undefined. So what the 2/5 is telling me is that I can use any number I want for x except 2 over 5. So to write the domain out, I'm going to use an old notation. All real numbers. This notation means all real numbers. This is telling me I can use any number I want for x. Any decimal, any fraction, any whole number, any negative numbers, any square root number, any number I want for x, except 205. So this is what my domain would be. All real numbers except 205. Number 34. We have f of x equal 12x minus 7 over 6x plus 5. We are trying to find the domain again. To find my domain, I'm going to take my denominator and set it equal to 0. I want to know what x value, when I plug it in, what x value is going to equal 0. Whatever x value I plug back in, it's going to equal 0. That is why I want to set it up like this. My goal is I do not want my answer to be over 0. I don't want that. So this is how I'll figure out what number will make my denominator equal 0. And that is why I want to set it up like this every time. I'm going to subtract 5 on both sides. So I have 6x equal negative 5. Divide both sides by 6. X is negative 5 over 6. Now, if you go back and plug in negative 5 over 6 for x here, then you'll see that your denominator will equal 0. My domain is all real numbers except negative 5 over 6. There are other notations that we can use to find domain. You have a set builder notation, and you also have an interval notation. So we may talk about those notations in this video, or I may wait and talk about it in the next video as part of our review. I just want you to be comfortable with how to find domain first, and then we'll talk about the notations after. Let's try another one. 35. I have f of x equal 2m squared plus 5m over 2m squared minus m minus 3. Okay, right here, I'm going to take my denominator and set it equal to 0. But tell me, how many answers will I have for m? And how do you know? How many answers will I have for m, and how do you know that? Thinking back to our previous sections, my degree tells me how many answers I will have for m. So what is your degree for your denominator? It is 2. That means I will have 2 numbers that I can't use for m. How do I figure out those 2 numbers? I need to take my denominator and write it in factored form. So I'm going to apply the master product method for my denominator only. What is 2 times negative 3? Negative 6. What multiplies to give me negative 6 and subtract to give me that negative 1? Well, I know negative 3 times 2 is negative 6, and then negative 3 plus 2 will give me negative 1 in the middle. So we're only focusing on the denominator. When we talk about domain, you only want to focus on that denominator. We have 2m squared minus 3m plus 2m minus 3 equals 0. So if you check your work right quick, I see 2m squared, negative 3 plus 2 is negative m, and then minus 3, and then I set it equal to 0 because we're going to start factoring it out. I see 1, 2, 3, 4 terms. Factor by grouping. In the first term, the GCF is M. I'm left with 2 minus 3. I'm left with 2M minus 3. Follow your sign. Now, what's my GCF here? It's only 1. What is left over is 2M minus 3. Set it all equal to 0. Now, we're going to factor again. So if I factor again, I have 2M minus 3 equals 0. And then M, well, I'm jumping ahead. Let me just show you. Factor again, I got 2M minus 3 times M plus 1. And now, it is in factor form. I have this times that. So if you have things multiplied together, you're looking good. And now let's solve for M. I have 2M minus 3 equals 0. 2M equal 3. Divide by 2. So M equals 3 halves. Then you have M plus 1 equals 0. So M equal negative 1. So what does this mean? This means for my domain, I can use any number I want except 2/3 and negative 1. I can use any number I want except 2/3 and negative 1. You try 36. You're going to still do the master product method in your denominator. And then you will have 2 numbers that you cannot use for your domain. Let's move forward to number 45. 45 says, write each expression in simplest form. If it is already in simplest form, so indicate. Assume that no denominators are 0. Again, we know numerator is the top and denominator is the bottom. Okay, so I'll make sure we know that. Let's look at 45. X squared plus 7x divided by 2x plus 14. What factoring method am I going to use? I'm going to use greatest common factor in the numerator and denominator. In my numerator, my GCF is x because both of them have an x in common. Now, I factor out one x, I have an x left over. I factor out this x, I have 7 left over. Now right here, I have to factor out a 2. I'm left with x plus 7. Now, I can cancel out x plus 7, and my answer is x over 2. If I ask you what's the domain, you're going to tell me all real numbers except negative 7, because 7 minus 7 will give me 0 in my denominator. So your domain will be all real numbers except negative 7. Number 47. 3x plus 15 over x squared minus 25. In my numerator, my greatest common factor is 3. 3 going to 3x, x times, plus 3 goes into 15 5 times. In my denominator, this is a perfect square. When I think about perfect squares, I want to think about conjugate. So we have x times x. The square root of 25 is 5. And then when we think about conjugate, the signs will be opposite of each other. what can I cancel out? So my answer is 3 over x minus 5. If I ask you what's the domain, you look at the original denominator factored out. X cannot be negative 5. X cannot be positive 5. Because if I plug those two numbers in, they're going to equal 0 in my denominator. So my domain cannot, it can be all real numbers except negative 5 and positive 5. I'm noticing that I'm canceling out some things. What does that mean? That means that if you cancel out something, there's a hole in the graph at that number. So right here, if I was to do the math for x plus 5 equal 0, x will equal negative 5. That means it's a hole at x equal negative 5. So you will have to work this out and tell me that the hole is at x equal negative 5. So let's talk about that again. If something cancels out, if my x's, anything with an x in it, if it cancels out, that is where you'll have a hole in your graph. And your hole will look like an open circle at negative 5, x equal negative 5. And we will hopefully look at some graphs so you can see that, or we'll look at a table and we can see that. Number 51. I have 10x minus 5 over 18x minus 9. I'm going to factor using my GCF. My GCF is 5. 5 goes into 10x 2x times. 5 going to 5 one time. My GCF here is 9. 9 goes into 18x 2x times. Minus 9 goes into 9 one time. So I'm going to cancel these out to 1. And my answer is 5 over 9. Number 63. Same directions. We have x squared minus 8x plus 15 over x squared minus x minus 6. In my numerator, I see a trinomial and a trinomial in my denominator. Both of them have a leading coefficient of positive 1. So I can do trial and error method. I need to figure out what two numbers will multiply to give me 15 and add to give me 8. I know that 5 times 3 is 15 and negative 5 minus 3 is negative 8 in the middle. When the last sign is plus, you write the first sign twice. I have x times x. What two numbers will multiply to give me 6 and subtract to give me 1? 3 times 2 is 6. Negative 3 plus 2 is negative 1 in the middle. I have a hole in my graph at x equal 3 because they canceled out. This part here didn't cancel out. This means I have a break at negative 2. I have a break in my graph at negative 2. And I may do a video just focusing on how to identify if it has a hole or a break in the graph. So, because we do have some students that are going on to another math class, so it's very important that you understand that for your other math classes. My answer is x minus 5 over x plus 2. Let's try another one. 67. 67, you have 2a to the third minus 16 over 2a squared plus 4a plus 8. In my numerator and denominator, I can factor my greatest common factor. In my numerator, what do they have in common? A 2. 2 goes into 2a to the third, a to the third times. 2 goes into 16, 8 times. I can factor out 2 in my denominator. 2 goes into a squared, 2a squared times. 2 goes into 4a, 2a times. 2 goes into 8, 4 times. In my numerator, I see a difference of 2 cubes. So bring down that 2, a little parentheses and a big parentheses. And you need to remember your sign order. Minus, plus, plus. You want to take the cube root of a to the third, which is a. Cube root of 8 is 2. Now, you have to square the a, square the 2, multiply 2 and a. Okay, now, do I see anything that I can cancel out? Right here, you can factor again if possible, because I need to find 2 numbers that will multiply to give me 4 and add to give me 2. And I know 2 times 2 adds to 4. 4 times 1 adds to 5. It doesn't give me 2 in the middle. So that cannot be factored out anymore. But I do see that these can cancel out, and then the 2's can cancel out. So my final answer is a minus 2. If I was to ask you to find the domain, I know there is 2 answers out there I can't use. So my domain would be all real numbers except whatever those 2 numbers were. I can't factor to find the 2 numbers, so you would have to do another method to find out what a is. You can do quadratic formula, or you can complete the square. But there's so many ways. Or you can just graph it and look at the graph. But we're going to talk about quadratic formula in this class towards the end. But we're not going to cover completing a square, and we're going to look at very little graphs. So but those are ways you can find out what the domain is. You can graph and look at it. You can plug it on your graphing calculator, look at your table. You can complete the square, and you do quadratic formula. So there's so many ways you can figure out what the domain is. But again, the question didn't ask for domain. It only asked me to simplify the problem, which I did, which was a minus 2. Okay, now look at 73. It says write each expression in simplest form. Assume it is already in simplest form. So if it is already in simplest form, so indicate. Assume that no denominators are 0. I have 4 times x plus 3 plus 4 over 3 times x plus 2 plus 6. You can do this a lot of ways. I see 2 parts. This is a part, and this is the second part. This is the first part, and that's the second part. Or, if I don't want to look at it like that, use the Schroeder property. 4 times x is 4x, and 4 times 3 is 12. I'm going to do it both ways so you can see which way you like. In my numerator, I'm going to just look at it as 2 separate parts. If I look at this as 2 separate parts, what's their greatest common factor? It is 4. So 4 going to the first part, x plus 3 times. And then 4 goes into 4 one time. That's the first part. Now, if you don't like that, you need to distribute. So I'm going to rewrite this as 3x plus 6 plus 6 again. So I have 3x plus 12. Now, what is my greatest common factor here? My greatest common factor is a 3. 3 goes into 3x, x times. 3 goes into 12 4 times. Definitely a little less work because this is pretty much done. This one's done, but I'm still have to work on this one. So I have 4 times x, 3 plus 1 is 4. And then my denominator is already finished, which is x plus 4. I will have a hole in my graph at x equal negative 4. They cancel out. I'm left with 4 over 3. So if you notice, I did my numerator and denominator very, very different. So whichever way you like the best, try it. You can either distribute, combine like terms, and then GCF, or look at these as two separate parts because the plus sign separates the parts. Do GCF, combine like terms, and then cancel out in the end. The next section has the same directions. So let's look at that again. Look at number 77. X to the third plus 1 divided by ax plus a plus x plus 1. In my numerator, I see a difference, a sum of 2 cubes. Little parentheses, big parentheses. Plus, minus, plus. The cube root of x to the third is x. The cube root of 1 is 1. Square root of x. Square root of 1. Combine the 2. Understood to be 1x in the middle. And my denominator, I see 4 terms. So I'm going to complete factor by grouping. A times ax plus a. I can factor out of a. I'm left with x plus a divided by a. A divided by a is 1. X and 1 has nothing in common, so I bring down plus 1. I'm left with x plus 1. Do my parentheses match? Yes. That lets me know I did it right. Is my denominator in factor form yet? No, because I see a plus sign. Factor form has to be something times something, etc. This does not say that. It says something plus something. That's why it's not in factor form yet. My numerator is good. It's in factor form. Look at this trinomial. Can I think of 2 things I can multiply to get 1 and add to get 1? Multiply to get 1 and add to get 1. So I can't find that because 1 plus 1 is 2. So this cannot be factored anymore. Bring down x plus 1 times x squared minus x plus 1. Factor your denominator one more time. My GCF is x plus 1. What is left over is x plus 1, a plus 1. Do I see anything get cancel out? A hole in my graph at x equal negative 1. What is left over? Well, what's left over is x squared minus 1 plus 1 over a plus 1. That is what's left over. And this, what I have boxed up, is my answer. Let's try another one. We're going to talk about the negative switch order. The negative switch order. What does that mean? I should see a negative sign. I'm going to switch something around, move it around, and it's going to be written in a certain order. I should see a negative sign. I should see something being moved around. I should see it moved around to a particular order. That's exactly what we're going to see. 81. I have x minus y over y minus x. What's the problem with 81? Well, the problem is that these are opposites. X, negative y, positive y. Those are opposites. They're not the same. So I can't cancel out yet. So we're going to apply that negative switch order. Now, I want to ask you another question. Which part looks normal? The numerator or denominator? Me looking at it, I say the numerator looks normal because I'm used to seeing x then y, not y and x. So I'm not going to mess with the numerator, but I am going to do something to the denominator. I want you to keep in mind, I'm not changing the problem. I'm only changing the look. That's it. If I factor out a negative sign, a negative times what makes y positive? Another negative. Two negatives make a positive y. A negative times what sign makes a minus x? A positive x. So if I factor out a negative, negative times negative is positive, negative times positive is negative. I didn't change anything. It looks exactly the same. It's the exact same problem. Now let's do our switch part. I have x minus y over negative. I'm going to switch the x and y around and say x minus y. I didn't change the problem. Negative times positive is negative. Negative times negative, positive. Everything's still the same. And these now cancel out. Think about what the definition of cancel means. It equals 1. So my answer is negative 1. And that's the negative switch order. Try number 83 and check your answer in the back as well. So that's it for this section. We covered a lot of new information. We talked about domain, the negative switch order. We talked about all these different factoring methods. So please continue to study. Any concerns or if you need help, let me know.